Hello, welcome to our last Q&A session. My name is Pavel Punsky, and I'm an engineer on the video team at Meta. Together with me today are Sean, Mandeep, Tsahi, Lian, Santosh, and Ishan to answer your questions based on their last sessions that you have watched. So let's start with Tsahi. The question was, is it Google Meet that already switched screen share over to AV1 or someone else as a trial? What do we know about
Well,
the usage of AV1?
so we don't know much. What we do know is that Cisco WebEx announced a year or two ago that they are starting to use AV1 for screen sharing on some devices in some scenarios, but that was about it. What we see now in Google Meet is that they are starting to experiment with AV1 in different ways. What we believe is that we're going to see them use AV1 in low bit rates during simulcast, or you'll be using VP8 or VP9 for the lower layers, but AV1 for the lowest bitrate, and in screen sharing. But it's not out yet. It's just things that you see and hints that we get from looking at the code and getting different bits and pieces of the SDPs from calls.
Thank you. Next question is to you, Mandeep. CPU and bandwidth restrictions were mentioned for the client in regard to logging and telemetry. How do you judge on the bandwidth, and how do you apply any throttling? Do you incorporate the bandwidth control for audio video?
Thanks. So I think the first thing I should point out is that the logging happens on a separate channel than the rest of the RTC communication, and we generally rely on the app infrastructure, so like Messenger or Instagram, like the standard infrastructure to do the uploading of logs. And there is some throttling implied, but we're very conscious about what we log, both for efficiency reasons and also for privacy concerns. So we're constantly working to make sure that we're only logging the data that we need. I think Ishan is a lot more versed in this topic on client-side logging. He might be able to add a few more details.
Yeah, totally. I can provide some details. So we do always want to make sure that logging does not compete in bandwidth with like audio and video. This is especially important for users on like low bandwidth scenarios. So we do a lot of benchmarking to make sure that we are logging as minimal data as possible and as efficiently as possible. All of our components are modular as well. So we have like good communication between the media components and the logging components to make sure like bandwidth is utilized efficiently. And also that is one reason why a lot of our logging happens at the end of the call, so that like there is less chances of competition between the two.
Thank you. Great answer. Now, Sean, question to you. How do you compare Python to something like Janus and MediaSoup? Other than use of Go's programming language, is there any intrinsic benefit to using Python for building the WebRTC backend?
I tend not to compare different implementations head to head. Like what my attitude on this is that depending on who you are, like you should use what works best for you. So if you have like a code, imagine if you have like all your code is already in JavaScript, it'd probably make more sense to use Janus. Or if like you feel really comfortable with like a config driven and you have some things like Janus RTP forwarders could be perfect if like you have that exact use case. So I've contributed to libdata channel, MediaSoup and Janus, and I think they all have like particular strengths. But the reasons that I care about Python or why I continue working on it is like for me it's an API, not a server. So like with Python, you can build SFUs, you can build media servers, but it's also used in a lot of like popular security cameras. People put Go on the cameras now, peer-to-peer networks and VPNs. So my attitude, or like what I've seen, is the fact that since Python has such a wide user base, that it's made the code base better, more resilient, and covers more things. And then leading into like, is the only reason to use Python is because of Go? Like that is a big part of it. Like Go is a fantastic programming language. Like it's built for teams. Like the fact that I have a package manager built in, the fact that it's really simple. Like I love that new grads can come on and start contributing to Python. Like that's that's really, and I think that same goes for like people building with Pion, that you can be starting out your company and know nothing about RTC and not be, you know, a C++ wizard, but you can go and pull Pion off. And then the last part that Pion that I think that makes it effective for people is it's more than just code. Like the Pion code base is split out. So, you know, like ICE is in its own repo and DTLS and RTCP. And the truth is, like, when you run it, you can go use a managed WebRTC service, but when you run into a problem, you're going to have to talk the language. Like, you're going to have to debug things. And it's not enough to just show up and say, like, oh, there's no video on the screen. And for me, like, that's why I do things like WebRTC for the curious, and I do these, and I don't have like a big mono repos because I want people to understand and know how to use things. So yeah, that's like, I break it. Those are like the three things that today keep me going is like, I think it's great as an API. I think it's like Go as a language is great. And Pion for me is becoming more and more about like the education of WebRTC and not just like a blob of software.
Great answer. Thank you, Sean. And if you all know, you can reach out to Sean on a Slack channel. Not promoted. Okay, next question, Santosh. What are the main challenges in building a simulator for RTC?
Yeah, thank you for the question. One of the biggest challenges that we faced is how to convert the production traces into like network profiles for simulations. For example, a production will have lots of different network types. So one thing that we did is like we have heuristics built on top of the production traces to convert them to network profiles. And we are experimenting with that for training our ML models. And also, our existing simulation tools are built on top of WebRTC's performance tests. There's nothing more big about building the simulation tool itself, but more about production traces. How do you convert into network profiles?
Thank you. Fantastic answer. Next question is to you, Tsahi. So, very serious question. How many balls can you juggle at the same time?
Well, I knew this was coming, so this is my maximum, 4. I do 3 clubs. I juggle twice torches. And I also juggle a single kettlebell, which is this huge weight.
But with all the seriousness, with so many changes in WebRTC, how should a developer keep up with the changes and the skills in this domain, especially for maybe for new developers that coming up to this area?
So I guess it's really hard. It starts with the fact that WebRTC is multidisciplinary to begin with. You need to know a bit about signaling and networking and browsers and voice over IP and how media is sent over the network and how codecs work and devices and peripherals and servers. So there is a lot to it. There is a WebRTC for the curious. It's an online book. Then there are my courses, the WebRTCcourse.com. There is WebRTC Insight Service. There is Discuss WebRTC, where you can ask questions, WebRTC hacks for the technical stuff when you actually go into deep diving into stuff. So I guess it's not a good answer because there's so much to go and look and see and be on top of. So you need to figure out your way in there. And also as a developer, what it is that you're most passionate about. Is it the optimization piece of it? Is it the codecs, the quality part, the monitoring and the logging part, the UI, and the fluidity of it? Once you pick that route, it's easier to go and dig deeper into that specific domain.
Thank you. Next question is to Mandeep and Ishan. So it seems like what Relegator doing is a stream processing. Have you considered using an off-the-shelf stream processing framework like Apache Flink? I think it's very relevant to people who are listening and watching this series today.
Yeah, so great question. I'm not familiar with that particular open source solution, but we have looked into our internal stream processing solutions at Meta. And generally, actually, the very first implementation before my time of Relegator was actually built on one of these stream processing solutions. And there were a few challenges it ran into, and one of them being there was limited support for working with multiple streams and processing multiple streams at the same time. And two, just our scale, it couldn't handle. And the main reason was the way we actually run our completion logic. It runs on a timer, and most stream processing frameworks don't have support for something like that. So you usually have all the data coming in, and even if you support multiple streams, you have to meet some condition when events arrive on one of those streams, and then write your output. Here we want to periodically run our output loop because we have timeouts. Sometimes some of the data that we're waiting on is never going to arrive. So that's one of the main reasons. Those are some of the main reasons.
Thank you. Lian, next question is for you. For machine learning-based bandwidth prediction, how big is the model compared to existing GCC? For reinforcement learning technique in the future plans, will it be done in deployment or in a production network that emulates typical deployment scenarios? What are your thoughts about it?
Thank you. That's a great question. So our model size depends on our model structure and the model complexity. So currently, our model size varies from like 20 KB to even 100 KB. That depends on our model complexity. So for the deployed model that we have currently, like congestion model and packet loss model, the model size is around 30 KB. So it's quite a small size model on device. And for the reinforcement learning technique in the future plan, we will test and iterate on simulated networks first. But our ultimate goal is to launch and deploy in the production environment. Thank you.
Thank you, Lian. Great answer. Sean, the next question is to you. What is your thought on running a company with fully open source product and trade-off between open source governance and philosophy and for-profit needs?
It's hard. It's definitely, and it's something that's new to me. I've only been doing this for 6 months. So for me with Pion, I always worked on things that like either I thought were deeply important to the quality of the project or were deeply important to the users of the project. And that's a pretty easy thing to do. Like I'm not being pulled in many different directions. And with LiveKit, now I have, users that are coming in from the open source side that, they're telling me things that are important. But the truth is that if you use LiveKit and you're not paying for it, that I can't keep working on LiveKit if you're not a paying customer yet. So like it's a very different reality. And so, yeah, like there are these things that you have to work on. But I've had this conversation with a lot of people, and one that really rang out with me, like, as I was talking to Colleen, and she was telling me, like, as long as you line up your incentives with your users, in the end, like, you will feel good about what you're doing and you will have good results. And so I'm trying really hard to do that. Like, there's no like simple, follow these 12 steps and you can have a great open source company. But I think I make sure, like, when I go and talk to customers, that I always recommend like what I believe is best for them. That when I go and build things, I'm trying to build things for like the long-term quality of the product, that I have to support growing LiveKit, but at the same, yeah. So I don't know. I could talk about this for hours, and there's all these like different things and points. But yeah, it's not easy, and like so many people struggle with it and talk about it, and I'm trying my best, and I'm happy to talk. I succeed the rest of my time because I could keep going. But yeah, that's where I'm at today. This is new to me and it's challenging, but we're trying our best.
I can feel pain as an open source project maintainer, not the same scale, but it definitely takes a lot of work. Next question, Santosh, is for you. Is it possible to run ML-based bandwidth estimation, congestion control on top of GCC in the browser? Is there any plan for that?
Thanks for the question. The currently developed models, we are running only on native apps, especially like mobile devices. We don't have immediate plan for running on browser, but the solution that we have developed so far is applicable for browsers. For example, you can run an ML model, and if you are able to intercept network signals, for example, RTT packet loss, jitter, as we mentioned in our talk, we should be able to like characterize network into different types and apply optimization. For example, WebRTC is mostly controlled to the field trial configurations, and if you can control that based on the network type, that's something is possible potentially for web browsers. Other than that, actually replacing the GCC module, we need to like work closely with the upstream WebRTC to change it for using ML-based approach.
Thank you. Thank you for your answer. Mandeep and Ishan, the next question is for you. You mentioned that the distributed key value store management is very expensive. Can you please elaborate on why is it so expensive?
So generally because there's replication involved. So you have to, there's the current internal key value store that we have, it does 5x replication. So that's 5x the data storage cost, and the data storage technology they use is usually flash or something expensive of that nature. And we necessarily don't need that type of latency for our use cases. And then again, you have to send all of that data over the wire, and then read it back once you've aggregated all the logs to process them and write out the aggregated results for our data pipelines. So mainly that sort of, amplification of the writes and then the reads is what makes it expensive. And the distributed sort of event processing system like Scribe that we have, it's already doing the replication, and so it has the data there if we wanted to reprocess it. So it generally would mostly be wasteful to use a well implemented key value distributed key value store. Yeah, thank you.
Thank you for your answer. Santosh and Leah, question to you. So I think it's a very generic question. It's very interesting. What's the biggest challenge you faced in training networking machine learning models for RTC? And I think that could be probably expanded to not only networking.
Cool. Thank you for this question. I was hoping someone would ask this question. The biggest problem that we faced is ground truth labeling, especially for devising a solution for BWE, where the ground truth is not present. Initially, we leverage simulation to train the model. What we noticed with using simulation for training the model is it doesn't generalize well for production networks. And since we wanted to see if we could move to like directly using production data for labeling, but the problem there is the data could be like wide varying characteristics. And we even tried unsupervised training for some of the classification tasks. With unsupervised, you don't need the labels. Rather, you use clustering like algorithms to classify networks into like a good bandwidth and bad bandwidth networks. But overall, we strongly believe that the performance of ML-based solution especially for bandwidth estimation depends on the ground truth. We are taking a careful approach here. We are trying to build a better production scenario, as we mentioned in the start of this question and answer session, for our simulations. With that, we should be able to have a good production-like networks imitated on simulations where we train the model. Thank you.
Thank you for a great answer. And this is going to be our last question. So, Tsahi, what is the area that fascinates you the most with WebRTC these days?
I think it's mostly where exactly we're going. On one hand, you see all of the industry and the vendors going towards machine learning and unbundling of WebRTC and how do you do stuff in a way that differentiates us from others on top of this open source thing called WebRTC inside browsers that limit what we can do. So that's one thing. While at the same time, there's let's try something new, not WebRTC. Let's use web transport with web codec and WebAssembly and see what we can get from that. How can we push the envelope there, and what use cases can we take away from WebRTC and do it in a different way? Again, for the purpose of differentiation. And then there is the new work around media over quick, like a brand new protocol that is going to be there to do things totally differently or the same, just under a different name. So where we're going to be in a few years now versus today is going to look very differently. And I just can't wait to see how would that develop, what will get us there.
Thank you. That's a great answer. So I actually have time for a few more questions. Ishan, the question is for you. Do you use observability metrics in real time and change call quality in real time? If you can give an example, if possible.
Yeah, that's a really good question. So, as we mentioned in like the future scope of our talk, this is not something that we do currently, but this is something that systems like Rallygator can make us possible. We can like stream logs continuously, and then we can monitor them and like debug real-time calls, and we can change configuration on the fly for adjusting things like call quality. So we definitely hope that in the coming years, we'll be able to do this effectively and get a lot of value out of it. And there is even the possibility of using even more advanced techniques like machine learning, which could do this like automatically after analyzing the calls. So I really look forward to the future scope in this area.
Thank you, Shan. And now really to the last question. Santosh and Liana, this question is for you, machine. Have you tried applying machine learning solutions for other networking problems beyond bandwidth estimation?
Yeah, I can answer this question. We tried for optimizing network resiliency by detecting packet loss. Other than that, most of the time we have spent on bandwidth estimation and improving the bandwidth estimation. One approach which is in development is generalized network characterization, where we categorize network into like multiple types, and it's a multitask learning approach that we are developing within our networking org. The idea there is to like once you have multiple signals from the generalized network characterization, can we do a holistic optimization across multiple modules? For example, bandwidth estimator, network resiliency, and transport. That is in development, and we look forward to launching it in production in the near future. Thank you.
Thank you. And that's a wrap. Thank you for joining us and the audience question that you submitted. Thank you all.